In this session, you will be learning the implementation of each and every component in a UVM test bench in detail. So the first one is the UVM test bench module. In any verification environment, there should be a final top level module set test bench, which will instantiate the top level DUT module and the class-based system verilog components. So this is true for UVM test bench also. This is a typical structure of a UVM based test bench final module. So the module name is test bench, and this pattern is true for every test bench in Systemverilog, except that there UVM has some additional components which will set up the actual UVM configurations. So first will be the instantiation of the internal signals. So next is the DUT instantiation, and if the DUT is not using a Systemverilog interface in them, you have to create your own interface to contain all the signals that is passing as the ports to the DUT, and you should create the instance of the interface in the top level module, because interface is needed for in the UVM or in any class based test bench to pass the actual workload content from a class based environment to the actual DUT. Next there will be clock and reset generation portions, and this is a portion which is specific to UVM. So the UVM configuration and component instantiation is done in an initial begin in the top level test bench. So within the initial begin, first we will set up all the configuration objects that is needed in the UVM environment. That is done by adding all those components into the UVM config DB. So UVM config DB, you can assume that it's a database to where you can put components or any Systemverilog modules or Systemverilog class handles, and use a name to indicate or to get reference to the particular component, and at any time we can get the handle from anywhere in the UVM components. So this is a general syntax to put or add any components to the UVM config DB. UVM config DB hash. Next is a type of the component that you're actually passing. So here first thing is we are passing the interfaces. So here virtual interface, this is AXI ADDR interface is the interface name, and colon set. Next is the arguments, and within the arguments you can see in details the implementation if you need it, but you can always use this format null star. Next is the actual handle, which is the instance of this particular write address interface, this one, and next is last is the actual handle, and this one is the name of setup. So this name is used to get this particular handle from the config DB from anywhere in the UVM component. So you need the interface handles in your driver in order to actually drive the transactions to the DUT. So in the driver you will be using this particular name AXIWADDR and INTF1, which is a string you can see. Using the same name you can get this handle, this particular interface handle, from the UVM config DB. You should put all the DUT interfaces into the UVM config DB which is needed from the UVM components. And after setting up the configurations like the virtual interfaces, and if there are some additional configurations which you need to pass, there also you can put here. And after that you will be running the actual test. So this is a format to run any test. You will call the function, this is a UVM function run test, and as an argument you can pass the name of the class, the test class which need to be run. So this is a name of a UVM test class, or which is a class which is extended from the UVM test, which will contain all the proper UVM instantiations. So you can call the test by using run test function. Either you can call it directly by passing the test name, or you can just put say run test without any argument. So if you're using this method, you have to use a runtime argument which is called plus UVM test underscore test name equal to the test name. So if you're using this method, you don't need to change the test bench code every time when you want to run a different test in the same environment. Thus, this is a recommended method. You should always use run test without an argument, and use the runtime argument plus UVM test name equal to the actual test name which need to be run in this particular simulation. So that it will the UVM will take this particular argument as a test name. So this is a setup for the UVM, and this is the general structure of any UVM top level test bench module.